We'll now talk about atomic masses, introduce the concept of a mole, and begin a discussion about molar masses. We're going to consider the isotope of carbon, carbon-12. Now, we define the mass of a single atom of carbon-12 as being exactly equal to 12 AMUs, or 12 atomic mass units, where one atomic mass unit is 1.66 times 10 to the minus 24 grams. Given that, we can calculate the mass of a single atom of carbon-12 in units of grams. So if 1 AMU is 1.66 times 10 to the minus 24 grams, then to find the mass of 12 AMUs, you would just multiply that by 12. Let's show that and show how we can convert the units using our conversion factor here. So we have 12 AMU in this carbon atom, and then we're going to multiply that by our conversion factor. We want AMUs to cancel out, so we're going to put the 1 AMU on the bottom, and then we want to go towards grams, so we'll put 1.66 times 10 to the minus 24 grams on the top. Doing it like that allows us to see how the atomic mass units cancel out, and it gets us into units of grams. And what we find is that the mass of this carbon atom is 12 times 1.66 times 10 to the minus 24, which comes out to 1.99 times 10 to the minus 23 grams. Now, is this a mass that we could easily measure in a lab? No. It doesn't matter how precise of a scale you have, there is no scale that can measure out and weigh out 1.99 times 10 to the minus 23 grams. But fortunately for us, we almost never would work with single atoms of carbon. We're typically working with very large quantities of carbon atoms. And that's where we get into the concept of moles. We need a way to represent a huge number of atoms, a number of atoms that would be on the scale of what it is that we work with in our everyday lives in a chemistry lab. And that is called the mole. Now, a mole is just a word that stands for a number. And we have lots of words that we use that represent numbers. Let's take a look at a few examples. For example, sometimes people use the word pair, and that indicates that you have 2 items. People will often use the word dozen, which stands for 12 items. The word billion stands for 1 times 10 to the 9th items. And the word mole is just a number. It stands for the number 6.022 times 10 to the 23 items. So if you have 6.022 times 10 to the 23 carbon atoms, then that means that you have a mole of carbon atoms. If you had 12 carbon atoms, then you'd say that you have a dozen carbon atoms. These are words that just represent numbers. That's all this is. That's all that a mole is. It's just a number. We call this Avogadro's number, and you'll see that term used a lot. So Avogadro's number is this value, 6.022 times 10 to the 23. All right, so given what Avogadro's number is, and given what the mass of a single atom of the carbon-12 isotope is, we'll now calculate the mass of 1 mole of carbon atoms. Let's think about how we would do that. If the question asked us instead, what's the mass of a dozen carbon atoms, you would multiply by 12. Right? If they asked you what's the mass of a pair of carbon atoms, you'd multiply by 2. So if they're asking you what's the mass of a mole of carbon atoms, you're going to multiply by Avogadro's number. Let's go ahead and do that. We have as the mass of 1 carbon atom, that's 1.99 times 10 to the minus 23 grams. And then we're going to multiply by Avogadro's number. And so we're going to multiply by 6.022 times 10 to the 23. And then that means that 1 mole goes on the bottom. All right, so you can go ahead and calculate this. When you multiply the mass of a single atom by Avogadro's number, what you're going to end up getting is 12.00, and the units are grams per mole. So what this says is that there are 12 grams of carbon in every mole of carbon atoms, 12 grams per mole. We call this the molar mass. What the molar mass tells us is how much a mole of something weighs. What's the mass per mole of the substance that you're studying? The periodic table contains information about molar masses, and we've talked a little bit about some of the boxes on the periodic table that show all of the elements. We've previously looked at the atomic number, which tells us the number of protons, and we've also looked at the atomic symbol before, but there's an additional piece of information in every square of the periodic table, and it's this value. This value represents, you could either look at it as being the average atomic mass in units of atomic mass units, or you can also see it as being the average molar mass in units of grams per mole. The units are interchangeable here. So for carbon, you'd say 12.01 AMUs is the average atomic mass, or you could say 12.01 grams per mole is the mass per mole, or the molar mass of carbon. All right. You might notice as you're looking at this that the value 12.01 that comes from the periodic table does not exactly equal the value of 12.00 that was calculated in the previous example. And in the next video, we'll talk about why that is and where this value of 12.01 comes from.